Okay, so special right triangles are either a 45, 45, 90 or a 30, 60, 90. And so we're going to use ratios, which we know how to do ratios because that's what we did in our last unit, to find missing side lengths. So in a 45, 45, 90, the legs are congruent. Okay. So our legs are congruent. If I know it's a 45, 45, 90, what kind of triangle is it? Isosceles. Okay, because we already know it's isosceles because two of our angles are the same. So these can also be called isosceles right triangles or right isosceles triangles. Either way. So it's a right angle and it's an isosceles. It's always going to be a 45, 45, 90. Okay, so our legs are congruent and the hypotenuse is square root of 2 times bigger than the legs. So it has a ratio of 1 to 1 to 1 square root of 2. Okay. So this is a picture of what it looks like. So we have a 45, 45, 90. Our hypotenuse is always the longest side. It's always across from that right angle. And so it's square root of 2 times bigger than the legs. So there's a bunch of different ways that you can figure these out. Easiest way is to use a ratio in similar triangles. So if I have a 45, 45, 90, our angle postulate tells us that all 45, 45, 90 triangles are similar. So we're going to set up a ratio using this triangle. Okay. So we have a 45, 45, 90. And we want to use a 1, 1, 1 square root of 2. Okay, so that is the triangle that we are going to be basing all of our triangles off of. Okay. So let's look at this first one. So in this first one, I've got 45, 45, 90. One of my legs is 8. So what is the other leg going to be? 8. Okay, because it's isosceles, our legs are the same. So if this one is 8, this one is 8. Question on that? Okay. So then we want to find the hypotenuse. So I'm going to set up a ratio using our triangle over here. Okay. So if I set up a ratio, I can say that 8 matches the 1. So I can say 8 over 1 equals, the x is the hypotenuse, so it matches the hypotenuse, which is 1 square root of 2. Okay. So setting up the ratio just like what we did all of last unit. And so now to solve it, we just cross multiply. So 1 times x is just x. And then when you multiply today, we don't want to lose the square root. Okay, we want to keep the square root. So when you multiply outside numbers together and you multiply inside numbers together. So on the outside I have 8 times 1, which is 8. And on the inside, all I have is square root of 2, so I get 8 square root of 2. That's it. Okay, don't change it to where it's a decimal or anything like that. You're just leaving it 8 square root of 2. X is by itself, so I'm done. Questions? Let's look at number 2. So number 2, I have 4 square root of 3. Is that a leg or a hypotenuse? A leg. So if this leg is 4 square root of 3, what's this other leg? 4 square root of 3. Good. So our legs are the same because it's isosceles. But the hypotenuse, I don't know. I have to find that. So again, I can set up my ratio. So I have 4 square root of 3. That's a leg. So it matches a leg, which is 1. So 4 square root of 3 over 1 equals, our hypotenuse we don't know, that's y. But our similar triangle, our hypotenuse is 1 square root of 2. Okay. So then again we want to cross multiply. So 1 times y is just y equals, and then again we multiply outside numbers together, we multiply inside numbers together. So on the outside I have 4 times 1, which is 4. On the inside I have square root of 3, square root of 2, so 3 times 2 is good. So our hypotenuse is 4 square root of 6. Questions on that? Okay, let's look at number 3. So number 3, I have 2 square root of 2. Is that a leg or a hypotenuse? The hypotenuse. Good, because it's across from the right angle. So I can see these are both x because they're going to be the same, but we have to figure out what those are. So our leg is x. It matches our leg up here, which is 1, equals our hypotenuse is 2 square root of 2 over, and then our hypotenuse is 1 square root of 2. So you're always using this same triangle to compare it to. So our legs are 1, hypotenuse is 1 square root of 2. So down here our legs are x, our hypotenuse is 2 square root of 2. Follow me, or no? Alright, let's cross multiply. So we do x times 1 square root of 2. Well, that gives me x square root of 2 equals 1 times 2 square root of 2 is just 2 square root of 2. Okay. So I want to get x by itself. If I have x times square root of 2, how would I get rid of that times? Divide. So we divide by square root of 2 on both sides. So my square root of 2's cancel. So x equals, well, if I look right here, what's square root of 2 divided by square root of 2? 1. So these cancel as well, so I'm just left with 2. So both of my legs are 2. Question? Alright, let's see if this helps. Let's look at 4. So on 4, I know 9. Is that hypotenuse or a leg? Hypotenuse. So I'm looking at my triangle here, and so I want to set up my ratios. Well, I know x and y are going to be the same because it's isosceles. It tells me these sides are the same, so these angles are the same. So then when I set up my ratio, the x matches the 1. The 9 matches the 1 square root of 2. Okay, and that's our same triangle from up top. I just flipped it around so it matched, like we're used to seeing. Okay. So again, we're just going to cross multiply. So x times 1 square root of 2 is x square root of 2. And then 1 times 9 is 9. So, again, we have x times that square root of 2, so we want to divide by square root of 2. So again, those cancel. And so 9 divided by square root of 2, I don't have 9's on the outside, 2's on the inside, so I can't simplify those. So I'm just going to leave it 9 over square root of 2. Now, okay, so, y'all do 5 and 6 real quick. Okay, let's talk about 5. So on 5, what did you get for the other leg? 14. Good. So your legs are always going to be the same. Good. How about for the hypotenuse? Good. 14 square root of 2. Good. So it gave us the 14. 14 matched the 1. So 14 over 1. And then we're looking for our hypotenuse, which was y. But the hypotenuse matched our hypotenuse of 1 square root of 2. Good. Any questions on that? Okay. So when you're given the leg, it should always follow the pattern leg, 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 square root of 2. So 14, 14, 14 square root of 2. On our first ones, we got 8, 8, 8 square root of 2. 4, well, 2 is a little bit different because we already had the square root. But alright, good. So how about number 6? What'd you get for the legs? Because they should have both been the same. Good. So 8 divided by square root of 2. Okay. So, again, we're looking for x. That matches our 1. The 8 matches the 1 square root of 2. So then if we cross multiply, 8x times 1 square root of 2 is x square root of 2. And 8 times 1 is 8. So then we divide by square root of 2. Now again, 8 is on the outside, 2 is on the inside, so you can't combine those, so you just leave it. 8 over square root of 2. Questions? Are we okay or no? Alright, good. So our next one is a 30, 60, 90. So a 30, 60, 90 is not isosceles, so none of our sides are going to be the same. So in this one, it's all based off of the shortest leg. Okay, so in a 30, 60, 90, the hypotenuse is 2 times longer than the shortest leg. And the longer leg is square root of 3 times longer than the shortest leg. So our ratio is 1 square root of 3 to 2. Okay. So same here. We've got x squared of 3, 2x. So you might ask, well, how do I know which leg is the shortest leg? The shortest leg is always across opposite of the 30. So if we draw our little line from the 30, that always takes us to the short leg. Okay. And then across from the 60 is always the long leg. And then, of course, across from the right angle is always your hypotenuse. Okay. So your short leg is always opposite of the 30-degree angle. Okay. So our triangle that we are going to base this off of is so our short leg across from the 30 is always going to be a 1. Across from the 60 is going to be 1 square root of 3. And then your hypotenuse is 2. So that is our triangle that we're saying is similar. And so again, because we know our angles, 30, 60, 90, angle postulate tells us all of 30, 60, 90s are similar. Now, the difference in these is that we are going to have to set up two ratios because none of our sides are going to be the same. So if we look at number 1, we have to find x and y. So again, we're matching to our triangle here. So I've got 60 degrees is here, which means 30 is here. So this is all based off of the short leg. Our short leg of 8 matches our short leg of 1. Okay, so 8 over 1 equals. Now if we want to find x first, that's our long leg. Our long leg of our similar triangle is 1 square root of 3. So x over 1 square root of 3. Okay. Any questions on that? So then we cross multiply. So x times 1 is x. 8 times the outside number, which is 1, is 8. And then the only thing I have inside is 3. X is by itself, so we're done. So 8 square root of 3. Questions? Okay. So then we also have to find y. Again, we can use our same 8 over 1 equals. And now we want our hypotenuse, which is y. Well, the hypotenuse of our similar triangle is always 2. So then if we cross multiply, 1 times y is y, and 8 times 2 is 16. Questions? Okay. So if we look at number 2, in this one I have 60. I have the 12, which is the long leg. So here's my 30. So x is my short leg. So if I look at my triangle that's similar, I have the long leg, which is 12. That matches my long leg of 1 square root of 3. Okay, so now I'm trying to find the short leg, which is x. That matches my short leg, which is 1. And so again, we're going to cross multiply. So x times 1 square root of 3 is x squared of 3 equals 12 times 1 is 12. So then to get x by itself, we divide by square root of 3. So we get x equals 12 divided by square root of 3. Alright, so then we also want to find y. That's our hypotenuse, so it matches our hypotenuse of 2. So now we have both of these. We have 12 square root of 3 and we have the 12. It don't matter which one that you use. We can use the 12 and the 1 square root of 3 because that's what we used last time. So if we do that, we've got 12 matches the 1 square root of 3, and then y is our hypotenuse, so it matches the 2. Okay, so 12 matches the 1 square root of 3, y matches the 2. And so then again, we're cross multiplying. So we get y squared of 3 equals 12 times 2 is 24. And then just like this last one, we want our square root of 3 to cancel, so we divide by square root of 3. So we get 24 over square root of 3. Questions? Okay. Alright, let's look at 3. So on 3, we're given 6, which is our hypotenuse. So y is going to be our long leg. Here's our 30. So x is going to be our short leg. Okay. So again, if we compare it to our triangle with the ratio, if we want to find x first, that's our short leg. Sorry. So it matches our short leg of 1. So x over 1 equals, and then 6 is our hypotenuse, it matches our hypotenuse of 2. So 6 over 2. So then again we can cross multiply. X times 2 is 2x. 1 times 6 is 6. So then what do I do to solve for x? Good, divide. So divide by 2. So x equals 3. So then to find y, our y is our long leg, so it matches 1 square root of 3. So we've got y over 1 square root of 3 equals, and then again we can do the 6 over 2. And then we cross multiply. 2 times y is 2y. 6 times 1 square root of 3 is 6 square root of 3. And then we divide by 2. Now in this one, we've got a 6 on the outside, 2's on the outside, so I can do 6 divided by 2. So that gives me 3, and then that square root of 3 stays the same because it's on the inside. So 3 square root of 3. Questions? Alright, y'all try 4, 5, and 6. let's talk about them. So for number 4, what did you get for y, the long leg? For y on number 4. Good. 20 square root 3. So the 20 matches the 1, because that's our short leg. And then y is the long leg, so it matches the 1 square root of 3. So then if we cross multiply, y equals 20 square root 3. Okay. How about for the x, what did you get? 40. Good. So that one, again, 20 matches the 1. The x matches the 2. So if we cross multiply, x equals 40. Good. Bless you. Question on that one. Alright. So then for 5, it gives you the long leg. I think these are the strangest ones because you end up with the weird dividing. So what did you get for x? Good. 20 over square root of 3. So the 20 matches the 1 square root of 3. The x matches the 1. So when you cross multiply, you get x squared root of 3 equals 20. So you have to divide by square root of 3. Good. So then what did you get for y? Good. 40 over square root of 3. So again, the 20 matches the 1 square root of 3. And then the hypotenuse matches the 2. So when we cross multiply, y square root of 3 equals 2 times 20 is 40. Then we divide by square root of 3. Good. So on number 6, what did you get for x, the short leg? 10. Perfect. And then how about for the long leg? Yes, so 10 square root of 3. Yeah. Yeah. Good, good, good. So on this one, the 20 is our hypotenuse, so it matches the 2. So 20 over 2, and then we want x, which matches the 1. So if we cross multiply, 2x equals 20, so x equals 10. And the other one, 20 matches the 2. The y matches 1 square root of 3. So if we cross multiply, we multiply 2y, and on the outside we have 20, on the outside we have 1. So 20, and then square root of 3, and then divide by 2. And then since the 20 is on the outside and the 2 is on the outside, you can simplify that to 10. And then the square root of 3 is on the inside, so you can't change it. Good. Any questions on this? So you're always using the same triangles to compare them to. Let's try some.